Okay, students, now we are going to start with the most important topic, structural aspects of the coordination compounds. In a complex, how to determine the structure. Okay, how to determine the structure, we are going to complete it today in this class. In this class, we are going to complete it by structure, how to find out the structure of a coordination compound. Okay, so let us see how you will be able to identify a compound structure. Okay, now before studying the structure, at least you should have a basic idea. You should have a basic idea about the coordination number. What you should have? Coordination number. Okay, now for easiness I am writing it with the short form CN. CN means coordination number. CN means what? Coordination number. Okay, so as of now there can be three coordination numbers. There can be how many coordination numbers? Three coordination number. I think everybody already must have idea coordination number. Number of lone pair accepted by a central metal ion is called as its coordination number. Number of lone pairs accepted by a number of lone pairs accepted by a central metal ion in a complex is called as coordination number. Okay, number of lone pair accepted by a metal ion or metal atom in a coordinate complex is called as coordination number. Okay, so as of now, for the exam point of view, these are the three essential. Other than this also possible, but 99% questions will be only these three coordination numbers. Okay, coordination number can be 4 and coordination number can be 5 as well as coordination number can be 6. Okay, now coordination number 4, that means there are two different structures are possible. Once you identify that, it is a coordination number 4. So but it does not mean that you have identified the structure. There are two possibilities are there. Okay, and here only one possibility is there. Here structure wise only one possibility, but energy wise two possibilities. Okay, so total how many type of hybridization we are going to study now? Total 5 types of hybridization, but comes under how many coordination numbers? Only 3 coordination number. Okay, once coordination number is 4, and after finding out the hybridization, if it founds to be sp3, if you find it to be sp3, that mean that time what will be the structure? It can be hybridization can be dsp2, hybridization can be what else? dsp2, and hybridization can be sp3d, otherwise dsp3. Okay, sp3d or dsp3. Is it understood, students? Now here major problem arises when in this one. Okay, sometimes we have to write d2sp3, sometimes we have to write sp3d2. Okay, so in this lecture I am going to give you, be with me with till last. Okay, so I am going to give you a wonderful technique to find out whether it is D2 or sp3. In fraction of second, you are able to identify when it is D2 sp3, when it is sp3 D2. Okay, a shortcut technique to find out whether it is D2 sp3 or sp3 D2. So stay tuned and stay with me, and you will be able to understand the logic in every point. In between I will be keep on giving you a techniques. Okay, so be with the notebook, especially in the inorganic side, in the coordination compound side. You should have a pen and notebook while attending this video lecture, so that you should keep on noting down the points, important points. Okay, the best notes in the world is the notes made by yourself for your own purpose. No other book can replace your notes. That's why you have to maintain a proper notes. Then only your revision will be proper and your score will be proper. For that, what you have to do? You have to be continuously attentive during the lecture. Wherever you feel that it is important, you write it in your notes. Okay. Now let's start with the coordination number 4. Okay. How to find out coordination number 4, and if coordination number 4, how to find out whether it is sp3 or whether it is dsp2. Okay, now for easiness, here only I will write the structures also. Okay, so if coordination number is 4, if coordination number is 4, and hybridization you find it to be sp3, then the structure is going to be tetrahedral. What hedral? Tetrahedral. The structure is going to be tetrahedral. Okay, and if it is coordination number is 4, but hybridization you find it to be square dsp2. That means the structure is going to be square planar. Structure is going to be what? Square planar. Okay, and here it is trigonal bipyramidal. In the exam also nowadays they are in a fashion to write it in a short form, TBP. TBP stands for trigonal bipyramidal. One triangle will be there. How many pyramids will be there? Two pyramids are going to be there. Okay. Now here D2 sp3 and sp3 D2, both structure wise same, but what is different? Very good. The energy is going to be different. Understood? Structure wise both are same. This is called as a low spin. Most important topic. And how to find out that? I'm going to give you a fraction of second trick at the last. Okay. Low spin, otherwise it is also called as inner. Okay, inner, otherwise it is also called as spin paired. What it is called as? Spin paired. Okay, see, these many names are given. That means these many MCQs you are going to attempt. Understood? More number of names, more number of questions you will be able to write. Okay, so again I am reading out: low spin, inner or spin paired. Low spin, inner or spin paired. Okay, same way, if you understand this properly, then you need not to worry about this. Just opposite to this, that is going to be like low spin. It is going to be what? High spin. Okay, here both of them shape will be, when coordination number is 4, the shape is going to be same. What is that shape? It is called as square bipyramidal. What it is called as? Square bipyramidal. Okay, bipyramidal. Instead of writing it so much lengthy, there is a shortcut also given. It is called as octahedral. What it is called as? Octahedral. Square bipyramidal or octahedral. Is it understood, students? So this is D2sp3, low spin or inner. Then it is octahedral only, low spin octahedral. Otherwise inner octahedral, spin paired octahedral. Okay. So it is high spin and it will be outer. Okay, and main here you should be spin free. What it is called as? Spin free octahedron. Okay, spin paired octahedron, and here it is going to be spin paired octahedron. Is it understood, students? Coordination number 4 will be giving you two structures. Coordination number 1 will be giving you one structure. Coordination number 6 also will be giving you one structure, but energy wise they are different. But what wise different? They are different in the energy wise. Okay, energy wise they are different. Okay, 4, 5 and 6. 4, 5 and 6. When coordination number is 4, then two structures. Coordination number 5, only one structure, one energy. When coordination number 6, two structures and two energies. Understood? So sp3d2 and d2sp3. What is the difference that we are going to study now? Is it understood, student? This is about the coordinate complex. Which complex? Coordinate complex. Now we are going to start one by one. Okay. Okay, now we are going to start one by one. The very first example I am going to take is NiCl4, NiCl4 2 negative. Okay, so first you should be able to understand what is the coordination number. Coordination number means each nickel gets 4 lone pair of electrons. Each nickel will get 4 lone pair of electrons from the 4 chlorine. So what will be the coordination number? 4. Coordination number is going to be 4. First and foremost procedure is to find out the coordination number. When coordination number is 4, then we will think about the structure, whether it is tetrahedral or square pyramidal, square planar, that we will come to know. Okay. Now, first we should write the electronic configuration. For easiness, for accuracy, without losing the accuracy, for speed, you should write the condensed electronic configuration. Which configuration? Condensed electronic configuration. Okay. So if it is 28 Coney, Fe Coney, okay, there is a technique to remember Fe Coney. Okay, Fe Coney means Fe means iron, Co means cobalt, Ni means nickel. 26, 27, 28. Okay, so Fe Coney means actually in the Hindi, don't throw it. In the Hindi, what is the meaning? Don't throw it. Fe Coney. Okay, so nickel 28. Okay, so here it will be helium, neon, argon, krypton. Okay, helium, neon, argon. So argon means 18 electron over. See, very, very important. I am writing it right side with gap. There is some purpose in it. Okay, 4s2. Then 20 electron, 3d8. This is the nickel configuration. Okay, the way I am writing, you should follow this only. This is what the problem when you go through the books. When you read the books, you don't know which is printed first and why it is printed first, before and last. Okay. So if you read from it 3d8 4s2, you will have a habit, but it is going to give you negative marks. How it is going to give you negative marks, I will tell you. Okay. So 4s to 3d5, 3d8. Now here oxidation number, each and every metal in a coordinate complex contains two numbers. Like nowadays it is a dual SIM phones are there. Earlier days only, since earlier days only, every metal possesses two numbers. Okay, like students have two numbers or not? One for family, another for friends. Likewise, every metal consists of two numbers. Okay, one is called as coordination number, another is called as oxidation number. Okay, so here -2 into 4, -4, sorry, -1 each oxidation number chlorine. Likewise 4 chlorines are there will be -4 oxidation number. Okay, but -4, the net charge is given as -2. That means we should write it as a +2. Okay, +2 -4 will result in a -2 oxidation number. Is it understood? So oxidation number is what? +2. Now, what you will write, you will eliminate two electron. What you will do? You will eliminate two electrons. Okay, from where you have to eliminate? From the valency shell. This is what I told you. Okay, so people says that sir, Bohr-Bury rule says something and you are doing something. Okay, that is the difference between you study from the books and you study from a teacher and you study from a video lecture. Okay, so audio lecture and video lecture. If you go through the video lecture and it is explained on the board in front of you, then that clarity will be very nice. Okay, so 4s to 3d8. So 2 electron. According to Bohr, what I should do like this, I should write. Okay, so then I will eliminate electron from this. But elimination of electron will always be from valency shell. Okay, to avoid making a such mistake by you people, this procedure I made it for you so that you should not get negative marks. Getting positive is different. Deliberately losing marks is very, very bad thing, which I don't want to happen with you people. Okay, so now this 2 electron will be eliminated. In the nickel +2, what will be eliminated? 2 electrons from here, it will be eliminated. Okay, so AR, and it will be 3d8. 4s will be what? 0. 4s 0. Is it understood, students? Now 3d8. See, d subshell contains 5 orbitals. And now which principle you have to use? Which principle you have to use? Okay, very nice. We have to use Hund's rule of maximum multiplicity. 1 electron distribute, then you start pairing up, and 4s will be 0. Now, here 4 chlorine minus are there. They are ready to give you. They are offering their lone pair of electron. Now, it's your duty to accommodate them. You should provide them a room. You should provide them a place to allocate the lone pair. Okay. So, normally we will use 4p. Okay. So how many people are coming? 4 people are coming. So we should give 4 places. So we will count it from here. 1, 2, 3, 4. So that means hybridization is going to be sp3 hybridization. Hybridization is going to be what? sp3 hybridization. Okay. Any doubt about this, students? Now hybridization is going to be sp3. And there is a magnetic nature also we can find out. 2 unpaired electrons are there. Therefore, it is paramagnetic. What magnetic? Paramagnetic. You can find out even magnetic moment also. What you can find out? Magnetic moment also you can find out. Okay. Now sp3, there is shape will be tetrahedral. Which hedral? Tetrahedral. Okay. So tetrahedral. Is it understood, students, how to find out the structure? If a coordination number is 4. One example for coordination number 4. Example sp3 hybridization. Metal is same. Now I am going to change with the ligand. I am going to change with the ligand. Okay. I am going to replace a weak field ligand with a strong field ligand. Strong field ligand means when it approaches to the metal, the electrons are so scared of it. Strong. The field is so much strong that electrons are scared of it. Okay. So they will try to go back to the original places when they see that lone pair, or when they see that what do you call, ligand. Okay. So that ligand is none other than Cn. Now it was Cl. Now I am going to replace it with Cn minus. Okay. So Cl is replaced with what now? Cn. Cl is replaced with what? Cn. Okay. So, but will it make any changes over here? No changes. Cn4 and oxidation number is going to be +2 only. Electronic configuration also. Second example I am taking. NiCl4 I have explained. What will be the hybridization? Hybridization will be, okay, hybridization will be sp3 only. Okay. But now I'm talking about the strong field ligand. Okay. How to find out strong field ligand, how to find out weak field ligand? There is a spectrochemical series. What is there? Spectrochemical series. It is going to give you a list of the all type of ligands, including what? Including weak field ligand and including strong field ligand. But for memory purpose, you should listen two things. What are the two strong field ligands? Cn minus and CO. These two are the strong field ligands. Okay, list of the strong field ligands which you must remember is Cn minus and CO minus. These are the strongest field ligand. There is nobody who is ready to face it. Okay. So here 3D8. Is it understood, students? Now I will be explaining this part. 3D8, though 4S0. Understood? This was the common thing. This was the common thing. Okay. Now 3D8 and 4S0. So 8 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 4S0 and 4P0. 4S0 and 4P0. Okay. Now here, when this strong field, we will write like in presence of SFL. What is here? SFL stands for strong field ligand. In place of the strong field ligand, this electron will come whenever there is a possibility. They will pair up. That is the beauty of that is the advantage. That is the stability. That is the strength of a field ligand. Understood? When they approach like this, they start pairing up. Okay. So now 3D8 is going to be 3D8 only. There is no problem with it. But the electronic configuration, the way of writing, it is against we are going some rule. What is that rule? Hund's rule of maximum multiplicity. Okay. We are writing this configuration against the strong field ligand. That is Hund's rule of maximum multiplicity. We are avoiding. Hunt says follow this rule, but we are going against the Hund's rule. Okay. I'm writing the electron from here to here. Okay. Now there is no unpaired electron here also, here also. Now still my requirement is 4 rooms only. but my requirement can be started from here itself. Earlier I started from here because they were not giving place to the Cl minus, because Cl is a weak. When a weak person comes, what he will do, he will sit in the place which is vacant already. But when a strong person approaches, then everybody will be afraid of it and give a place to him, comfortable place to him. Like that, Cn minus is a strong person. When he approaches him, he will replace. All of them will try to give place to him. Okay. So now the place is started from d orbital only. State is started from the d orbital. But our requirement is 4 orbitals only. 1, 2, 3, 4. Okay. So hybridization is going to be what? Instead of sp3, it is dsp2. What will be the hybridization, students? dsp2. That is the difference in hybridization. Earlier structure was tetrahedral. Now structure is square planar. Only one replacement. We are replaced the weak field ligand with the strong field ligand. That changed the entire scene. Structure is changed, and one more change I am going to emphasize on it is here there is no unpaired electron. So it will become diamagnetic. Which magnetic? Diamagnetic. Okay, is it understood, students? So this is the change when a weak field ligand replaced by strong field ligand. Okay, any doubt about this? Okay, there is no doubt. Then we will start with the next part. Okay, students, now after successful completion of examples of coordination number 4, now here we are with the coordination number 5, that is FeCO5. Okay, so FeCO5 is for coordination number 5. So what it should be the structure? D2sp3 or sp3d2, both are possible. Let's see the possibility. Okay, now before that, what you should know, coordination number is 5. Just having a glance it is known. Each carbon monoxide will give you one lone pair, 5 carbon monoxide, 5 coordination number. Then oxidation number is 0. Okay, so there is a technique to remember. All homoleptic. Which leptic? All homoleptic. Homoleptic metal carbonyls. Which carbonyls? Metal carbonyls. Okay, in all homoleptic metal carbonyls, oxidation number of metal is nothing other than 0. Okay, if entire complex, if you find carbon monoxide is the only complex, only ligand, blindly oxidation number is going to be how much? 0. This is the trick to remember. Without forgetting, without solving anything, you are going to score a good marks of the oxidation number. Okay, homoleptic means all are same type of ligand. What is that ligand? Carbon monoxide. Okay, now already I told you technique to remember, Fekoni. What I told you, Fekoni, iron, cobalt and nickel. Okay, 26, 27, 28. 26 is the atomic number of iron. What is the atomic number? 26 is the atomic number of iron. Okay. Now for the 26, as I told you, first you should write the electronic configuration of atom. Okay. So 26 will be helium, neon, argon. And it is 4s, sorry, I should give a gap, 4s2 and 3d, 20 and 6, 26. 4s2 when you write 20 electron, you are finishing off 18 to 20. Okay, then it will be 4p. Is it understood, students? So 1, 2, 3, 4, 5 and 1, 2 and 1, 2. Okay, so 3d 6. What is the hybridized electrons as per this? As per Hunt's rule, it should be the electronic configuration 4s2. Okay, now oxidation number is 0. What is oxidation number? 0, because it is a homoleptic metal carbonyl. Okay, so this and carbon monoxide, just now I told you two strong field ligand. List of the strong field ligands are mainly you have to remember for a competition, CO and Cn minus. These are the two strong field. Here strong field ligand is there. Then we should go in opposite to the Which rule? Hund's rule of maximum multiplicity. Pairing against Hund's rule. So this will come and pair up here. This will come and pair up here. This will come and pair up here. Okay. So 3d6 there is no change, but way of writing electronic configuration is, sorry, 3d6 is there. Now it will become 3d8. Two electrons came from here to here. Okay. So what will be the structure now? 8 electron I have to fill it up. Okay. And coordination number is how much? Coordination number is 5. So I should start from here. 1, 2, 3, 4, 5. So it is DSP3. What is the hybridization? Hybridization is going to be DSP3 hybridization. Okay. So for DSP3 hybridization, what should be the shape? TBP, trigonal bipyramidal. Now I think all of you are smart enough to find out the magnetic nature. Magnetic nature is this paramagnetic or diamagnetic, that you should say. Okay, very good. It is diamagnetic because no unpaired electrons are there. Okay, so due to absence of unpaired electrons, it is diamagnetic. Which magnetic? Diamagnetic. Is it understood, students? So we have finished with the fifth coordination number. Okay, any doubt about this? Now coming to the next part, next segment. Okay, now we are into the next segment, coordination number 6. Coordination number 6 is the main toughest task. Okay, so in coordination number 6, it will be difficult to find out whether it is D2sp3 or sp3d2. In the end, I am going to give you technique to find out whether it is D2sp3 or sp3d2, shortcut technique. Okay, so first let us see the procedure. Understood? Suppose Cr, okay, Cr H2O6 and it is 3 plus. Okay, so here coordination number is how much? 6. Coordination number is how much? 6. Okay, so in coordination number 6, that directly find out, and oxidation number, water is a neutral ligand. So oxidation number will be how much? Oxidation number is going to be 0. Okay, is it understood, students? Now after coordination number 6 and oxidation number, sorry, plus 3. Here oxidation number, it is not visible. Okay, oxidation number is equal to plus 3 from here to here. Okay, now I have to remove 3 electrons from the chromium. Chromium atomic number is 4, 24. Okay, so chromium 24. So helium, neon, argon. Okay, 4s1, 3d5. I think everybody remembered this is exceptional configuration for, there is exceptional configuration for what? Very good. For chromium to have what? Unpaired electrons, maximum number of unpaired electron and paramagnetic nature and half field stability. This is the configuration. Okay. So this is the 5 electron, 1, 2, 3, 4, 5, and there is 1 electron. But we are not going to deal with the chromium. We are going to deal with the plus 3 oxidation state. We are going to deal with which oxidation state? Plus 3. So here AR, 3 electrons I have to remove. 1 electron will be out from here, 2 from here. So 3D will be how many? 3D3. What will the oxidation number? Electrons will be 3D3. 4 is 0. Okay. So 1, 2, 3. 4 is 0. Are they sufficient for us? No. 6 people are coming. It's our liability. It's our responsibility to provide them sufficient place. We should be providing them 3 more places that will be provided from the 4p. Okay. So from here to here. Is it understood? So D2 sp3. What is the hybridization? It is going to be D2sp3. That is inner or spin paired. Sorry, spin paired. Okay, or low spin octahedron. Is it understood? So why here? Because it D3 configuration already place is there. Understood? Next, after CrOH2O6, I am going to take one more example. Coordination number is same, but structure is going to be different. For that, I am going to change two things. Okay, in place of the chromium I am taking cobalt. Okay, cobalt. In place of the chromium, what I am taking? Cobalt. Okay, COH2O6. And for easiness, I will change this also. I will change this also, so that more topics should be covered. CuCl6, and it will be 3 minus. Here still coordination number will be 6 only, and oxidation number will be plus 3 only. Okay, Faconi. So 26, 27. Cobalt will be 2, 7, 27. So 4s2 20, 3d 7. Okay, so 3d 7 is there. Now what happens? 7 electrons, 4s2 3d 7. Okay, now here cobalt oxidation number is plus 3. So 3 electrons must be out. 2 will be from here and 1 will be from here. Okay, 1 will be from here. So it will be 3d6 4s0. 3d6 and 4s0. Is it understood, students? So 3d6 and 4s0. Okay, 4s0 and 4p0. Understood? Now chlorine is a strong field ligand or weak field ligand? Very good. It is a weak field ligand. What are the two strong field ligands? CO and Cn minus. You have to remember strong field ligands. Okay. So 3d6. Now there will be hybridization will start from here itself. Okay. 4p and 4d also we will be using. For convenience, I will write it somewhere here. Okay. So it will be 3d6, 4s0, 4p0, 4d also we have to use here. Okay, because it is a weak field ligand and it cannot get electrons paired up. Okay, 4s0, 4p0 and 4d0. Okay, so this is a weak field ligand, pairing will not take place. So hybridization will start from here. 1, 2, 3, 4, 5, 6. So hybridization will be sp3d2. What is called as outer octahedron. Earlier it was inner octahedron and now it is outer octahedron. Okay. Now here I am making a little change. Okay. So in place of the Cl, if I write as Cn, okay, will there any change in oxidation number? All everything will be same. Okay, so in here this pairing will takes place. What will takes place? Pairing will take place. This will come over here. This will come over here. Okay, so because of that, hybridization will start from here itself. Okay, so that time what will be the hybridization? Hybridization will be D2sp3. Let me draw you and let me write it clearly. Okay, students, see here. Now we are in the coordination number 6, but I have replaced the chlorine minus with what? Cn minus. Okay, now the Cn minus is a strong field ligand, then pairing will takes place here. Okay, pairing will takes place from here to here and from here to here. So 3d6 is going to be same 3d6 only. Okay, but the magnetic nature have changed a lot. Earlier it used to be what? It used to be what? Okay, good. Okay, so it is used to be paramagnetic, but now it is diamagnetic. 4s0 and 4p0. Okay, so hybridization is going to be D2sp3. D2sp. The central metal same, coordination number same, everything is same, but still a lot of changes take place. It is now strong field ligand, therefore it will form V inner octahedron. What octahedron? Inner octahedron. Okay. So this is all about the structures of coordination number 4, coordination number 5, and coordination number 6. Okay. Now the shortcut technique. Okay, so for easiness, I'm dividing the configuration into 3 parts. Okay, D1 to D3, D4 to D6, and D7 to D10. Okay, so here D1 to D3, blindly you always write. If coordination number is 6, always D2sp3. Let it be strong field or weak field. Okay, it is always. And I am talking when coordination number is 6. After ensuring that, then only the problem arises. When coordination number is 6 and configuration is 3D1, 4D1, 3D3, no problem at all. Okay, D2sp3 always, irrespective of nature of weak field or strong field. Okay, now let us see D7. D7 means D7 electrons are there. 1, 2, 3, 4, 5, 6, 7. Okay, so let us suppose one electron comes over here. Will it be able to form D2sp3? No. Okay, let it be strong field also, let it be weak field also. It is not able to provide. It is not able to provide you with unpaired electron from the inner shell. Okay, so it is always sp3d2. It is always sp3d2. Let it be weak field or let it be strong field. Okay, but here comes the question. Okay, it will be D2sp3. D2sp3 if it is a ligand is SFL, strong field ligand. Okay, sp3d2 if it is a WFL, weak field ligand. What is SFL? What is the WFL? Already I told you. For that you have to consult spectrochemical series. Okay, this shortcut will enable you, will help you to solve questions of D2sp3 and sp3d2 in fraction of seconds. Okay, I think all of you understood clearly, and I think it is a good technique to understand and good technique to apply, score high in your examination. Thank you, and be with me. Learn more and achieve more. Bye.